Hello everyone, I am Bramlin and I am here to explain you about Einstein's theory of photoelectric effect. Let's start the topic. In 1905, Einstein explained about photoelectric effect on the basis of Planck's quantum theory. Let's see what was Planck's quantum theory. Planck's quantum theory. It states that a light radiation travels in the form of discrete photons. The energy of each photon is h mu, where h is Planck's constant and mu is frequency of light. Here are some main points of Einstein's photoelectric effect. First, photoelectric emission is result of interaction of two particles. The free electrons are bound to the metal surface. The minimum energy required to lose an electron from the surface, which is equal to the work function W0 of the metal. It means that a metal surface consists of many free electrons. The minimum energy that is required to lose an electron from the surface is equal to the work function. Third, each photon interacts with one electron. The energy of photon is divided in two parts. First, liberating electron from metal surface, and second, remaining is used in giving kinetic energy to the ejected electrons. Here is a simple diagram that can explain you about electron ejection. Fourth, very few photons are present whose energy is greater than work function and are capable of ejecting photoelectrons. Here is the definition of photoelectrons. As we talked earlier, energy of photon is divided into two parts. Here are they. First, W, which stands for the work function that is used for liberating the electron. Second is kinetic energy, which is given to electron when it is ejected. These equations are known as Einstein's photoelectric equations and can be used to explain the laws of photoelectric effect. Einstein's photoelectric equations are very useful. They can explain us about effect of intensity, threshold frequency, kinetic energy and time lag. Explanation of effect of intensity. Simply, intensity means the number of photons striking the metal surface per unit time. So we can say that as the intensity increases, the number of photons that are striking increases. We know that one photon ejects one electron. So we can say that as the intensity increases, the number of ejected photoelectrons increases. Explanation of threshold frequency. If the frequency of incident radiation is less than the threshold frequency, the kinetic energy of photoelectrons becomes negative. So photoelectric emission does not take place below the threshold frequency. From here we can define threshold frequency as the minimum frequency required to eject a photoelectron from the metal surface. Explanation of kinetic energy. The maximum kinetic energy of the electron increases with frequency mu of the incident radiation. Moreover, the increase in intensity increases only the number of incident photons and not their energy. Hence, the maximum kinetic energy of the photoelectrons is independent of the intensity of incident radiation. Explanation of time lag. There is no time lag between the incidence of photons and emission of photoelectrons in photoelectric effect. The electron is emitted instantaneously with kinetic energy equal to the difference between the energy of incident photon and the threshold frequency.